In this lesson, we're going to work with quadratic functions. Now what I have here is a graph of a quadratic. Now you might recall that when you graph a quadratic function, what you get is a parabola. A parabola is a U-shaped figure. Now it can face up or down or side to side. The parabola that we have here is facing upwards. Now I just want to talk about a few different ways that we can express the quadratic function that generated this parabola. Now the first way that you can write a quadratic equation is in standard form. There's also another form, which is called vertex form. And when you're working with a quadratic in vertex form, it's a little bit easier to identify certain features of the quadratic. And I'll explain those features in a second. But first, let me show you vertex form. So here you have y equals a times the quantity x minus h squared plus k. And in vertex form, what you can get from this is that h and k tell you about the vertex. H and k actually are the coordinates of the vertex. So this is helpful if you need to know the vertex. So looking at this parabola here, because the parabola faces up, the vertex represents a minimum value, right? No points on this parabola go below the point I just labeled. Now when the parabola faces upward and you have a minimum, the value of the minimum is the y coordinate of the vertex. So you have k. In this case, k equals -2 because we can see that the minimum corresponds to y equals -2. And you can take a look at the x coordinate here to find the coordinates all around for the vertex, right? So the x coordinate of the minimum is 2, which means the vertex is at 2, -2. Now let's take a look at a different type of parabola. Okay, here's a different type of parabola. And as we can see here, the parabola is opening downwards or facing downwards. So what we're going to have is the vertex will now represent a maximum value, right? No point on the parabola goes above this y value. Something else I want to mention. Notice here in the vertex form you have the coefficient of a in front. If a is positive, right, so a is positive, then the parabola is going to be opening upwards. If a is negative, then the parabola opens downwards. So what does that mean about the parabola I'm showing you now? Well, it opens downwards, so this means a equals a negative value, so it's going to be negative. And next, we can talk about the vertex as well. If you notice here, the vertex occurs at the x-coordinate -1, so x equals -1 at the vertex, which means h equals -1 if we're talking about vertex form, right? And what is the y value? Well, this happens or occurs right on the x-axis, which means the y value of the vertex is 0, or if we're doing the vertex form, we're talking about k, so k equals 0, and our vertex has the coordinates -1, 0, where 0, or y equals 0, is the maximum value for this parabola. Now let's practice taking a quadratic that's expressed in vertex form and rewriting it in standard form. So let's just scroll down here. And what if you were given a quadratic as y equals the quantity of x minus 3 squared minus 1. Now again, we're trying to get to standard form from this, which is ax squared plus bx plus c. That's standard form. So how do we convert this? Well, what we want to do is begin by expanding the parentheses and then following the correct order of operations. So to expand the parentheses, you would multiply x minus 3 times x minus 3 and then include that minus 1. When you expand and you factor, or I'm sorry, when you expand these parentheses, you get x squared minus 6x plus 9 minus 1. Now go with your order of operations and combine like terms. The only two like terms you have here are the 9 and the 1. So x squared stays the same, minus 6x stays the same, and then 9 minus 1 is positive 8. So you end up with that. So now you've got your quadratic expressed in standard form. Now we can also write this quadratic in factored form. And the way you do that is you could do any way that you know best how to factor. I'm not going to show you how to factor it. But basically, when you factor it, you get down to two binomials. So you get x minus 4 times x minus 2. This is the factored form of this quadratic equation. Now, as you can see, we've been able to algebraically manipulate these forms into other forms, which means that no matter which form you use to generate the graph of this quadratic, you'll end up with the same graph. So let's take a look at this. So going back to the vertex form, right, which is right here, notice that the coefficient in front of the parentheses is positive, right? And we're assuming right now that there's a 1 here, and it's positive because we don't see a negative sign. So that's why our parabola is opening upwards. Now again, we have the K and H thing here, right, which tells us the vertex, so H and K. H in this case is 3, and K is -1. So let's go ahead and look at our graph. Do we get a vertex of 3, -1? So here's 3, -1. Yes, we do. We get a vertex, and because this is opening upwards, this is our minimum value for the parabola. Now what I want to do is I want to take a quadratic that's expressed in standard form and rewrite it in vertex form using a method called completing the square. Let's take a look at that now together. Okay, here's a quadratic in standard form. And what I want to do is just review something with you. So let's just say we wanted to solve this quadratic, right? Which we're not going to do, but this helps me explain completing the square a little bit better. So if we were going to solve this quadratic, we would set it equal to 0, right? And now what we'd want to do is we'd want to factor the left side of the equation so that we could begin to solve. You need the left side to be a perfect square or factorable in some way that you can end up with something like x minus a value times x minus another, right? So you want it to be able to factor to something that looks like this. Now, it doesn't have to be minus signs, but this is roughly what you're going for. Now, what happens though if your equation, so this would be an example of a perfect square, right? Because I'm multiplying the same thing by itself, so I know that this represents x plus a squared, which is something I can take the square root of. What happens if I expand these parentheses here? What do I get? Well, I get x squared plus 2ax plus a squared. Now, this is another way of writing the standard form of a quadratic. And I'm going to use this to help us complete the square over here with this quadratic that I've written to start with. Now that means that we have to do some manipulation. The first thing I want to do is take a look over here. If this were factorable to a perfect square, right? If x squared minus 4x minus 12 could factor to something that looked like this, right? Then that means that what you have here, right? 4x, that represents 2ax because that's where we have it here. So 4x equals 2ax. Now I want to solve for a, and to do that I'm going to divide both sides by 2x. When you divide both sides by 2x, you get down to a equals 2, or 2 equals a, whichever way you put it. And then now for this other standard form, I need to know a squared, and a squared will be a times itself, so 2 squared is 4, so that's what a squared is. Now let's keep this in the back of our minds, okay? Let's go over here. The first step when you want to complete the square is take a look. Is this factorable? If it's factorable, then 2ax, which is 4x, right? That represents 2x, should be able to give you a coefficient where you square a and you get 4. But when you square it, you see that there's 12 here for a squared, and we're looking for a squared to be 4, which isn't the case. So what we need to do is move 12 to the other side of the equal sign. So do that by adding 12 to each side. So I'm just going to leave this area blank for now because we're going to fill something else in there. So add 12 to both sides. Y equals plus 12. And now what I want to do to complete the square is I'm going to add a squared to both sides. And I'm doing this because if I add a squared to both sides, I know the left side of the equation will become something that is a perfect square. And that's why we call this completing the square. So add a squared. And this is all like legal, I guess you could call it, in terms of algebraic rules, because we're doing the same thing to both sides of the equation each time. We're keeping everything balanced. So we're still within the limits of what we're able to do. So now we know that a squared has a value of 4. So I'm going to just replace that. (12 plus 4). Now simplify by adding 12 plus 4. So you get y plus 16 on the right, and then this is good to go over here on the left. Nothing changes. Now what I'm going to do is I'm going to factor the left side. When you factor, this is a perfect square, so it's going to come down to something like, what I've shown you here, or it's going to be like this, okay? So when you factor this, you get x minus 2 times x minus 2 equals y plus 16. And you can rewrite the left side as x minus 2 squared equals y plus 16. Now to finish writing this in vertex form, you're going to subtract 16 from both sides. So you get x minus 2 squared minus 16 equals y. Now let's just rewrite that with y on the left side. Again, you assume a coefficient of 1 here. I'm just going to draw that in momentarily. So x minus 2 squared minus 16. This is the quadratic in vertex form. Okay, let's just make some space and remind ourselves of how the standard, way of writing it is. Not standard form, sorry. But the way you write vertex form in general is y equals a times x minus h squared plus k. So what does that mean? Well, we're going to be able to find h and k. So we're going to be able to find our vertex now. Okay, so h is 2. And k, since k is normally plus k, we see a minus here, which means that k has a negative value. So k is negative 16. And this represents the vertex of the quadratic. Again, we notice that the a value, this is a right here, a is positive, so the parabola should open upwards. Let's take a look at the graph. We have the vertex of 2, negative 16. It should be opening upward, which means negative 16 should be a minimum. And here's our vertex, and it is a minimum. There are no points that lie below this, and the parabola is opening upwards. In this lesson, you've practiced working with 2 different forms of quadratic equations. You've also learned how to complete the square. I hope this makes some problems a little bit easier for you. Thanks for watching.